Welcome back to our notes for the unit circle, and in example 1 we're looking at the pi over 4 reference angle. So recall that there are 2 pi radians in an entire circle, and if I divide that circle, that 2 pi radians, into 8 congruent sectors, that would be 2 pi over 8, which reduces to pi over 4. So starting at 0 radians, this would be 0 radians, 1/8 of the circle would be 1 pi over 4 radians. Then 2 pi over 4, which reduces to pi over 2. Next would be 3 pi over 4. Then 4 pi over 4, which reduces to pi. 5 pi over 4. 6 pi over 4, which reduces to 3 pi over 2. 7 pi over 4. And then 8 pi over 4 is 1 full revolution, and that reduces to 2 pi. So as we count around the circle, that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And recall that these quadrantals reduce to pi over 2, 4 pi over 4 is pi, 6 pi over 4 is 3 pi over 2, and 8 pi over 4 is 2 pi, and that matches the quadrantal measurements that we had in the first page. Okay, now we're going to do that, but in degrees. So if you recall, there are 360 degrees in one revolution of the circle, and we're dividing the circle into 8 congruent sectors. That makes each one 45 degrees. So we're going to count around our circle in degrees now, starting at 0, and this would be 45 degrees. Then 2 times 45 is 90 degrees. 3 times 45 is 135 degrees. Then 4 times 45 is 180 degrees. 5 times 45 is 225 degrees. 6 times 45 is 270. Then 7 times 45 is 315 degrees. And 8 times 45 is 1 full revolution around the circle and brings us back to 360 degrees. Okay, next we want to find the coordinate at each one of these angles going around the circle. And we already know the coordinates of the quadrantal angles. So at 0, we have the point 1, 0. Then at pi over 2 is the coordinate 0, 1. At pi, we have a coordinate of -1, 0. And then at 3 pi over 2 is our point 0, -1. Now to find the coordinate of this point, where the terminal side of our 45-degree angle intersects with the circle, I'm going to pull that triangle, that reference triangle, out to the side here, and we'll recall that that point, the coordinate we're looking for, is the point x, y. where the horizontal distance is x, the vertical distance is y, and the hypotenuse, this hypotenuse is the radius of the circle. And since this is a unit circle, the radius is 1. So the hypotenuse of this right triangle is 1. Okay, this reference triangle came from the central angle that measured 45 degrees, which makes this a 45, 45, 90 special right triangle. And in geometry, you learned the rule for 45, 45, 90 triangles, that the hypotenuse is always the square root of 2 times the sides. So if my hypotenuse is 1, I would divide by square root of 2 to find the length of the sides. And 1 divided by the square root of 2, we have to rationalize that denominator by multiplying by root 2 over root 2, and that gives us a side of square root of 2 over 2. So the x coordinate of our ordered pair is square root of 2 over 2, and the y coordinate of our ordered pair is also square root of 2 over 2. So this coordinate for the 45 degree or pi over 4 reference angle is square root of 2 over 2, comma, square root of 2 over 2. Now, if I take that reference angle and I reflect that into quadrant 2. So we're going to take this point now and drop it down to make a perpendicular. And so here is my reference triangle in quadrant 2. That means I'm taking this point, root 2 over 2, comma, root 2 over 2, I'm flipping it or reflecting it over the y-axis. So now it has the same vertical distance of y, but the horizontal distance, its magnitude is the same. It's still x units, but it's to the left of the origin instead of the right of the origin. So the y stays the same, but the x is going to be negative because we're to the left of the origin. So this ordered pair is negative root 2 over 2, comma, root 2 over 2. Okay, similarly, if I reflect that reference triangle into quadrant 3, now I'm going to have a coordinate where both the x and the y are negative. So the magnitude stays the same, the sign changes. And then reflecting into the fourth quadrant, this is where x is positive, but y is negative. So positive root 2 over 2, negative root 2 over 2. Okay, so you want to pause the video and practice filling in the blank unit circle template. This time filling in not just your quadrantal special angles, but any of the pi over 4 reference angles as well. And when you're ready to check it, we'll go over it together. So starting in degrees, we are at 0 degrees, and 1 full revolution around the circle is 360 degrees. Half of that is 180, half of that is 90, and half of 90 is 45. So starting at 0, we've got 45 degrees. 2 times 45 is 90. 3 times 45 is 135. Then 4 times 45 is 180. 5 times 45 is 225. Then 6 times 45 is 270. 7 times 45 is 315. And then 8 times 45 gets us back to 360. Okay, next we're going to go around the circle in radians, starting with 0 radians. 1 full revolution around the circle is 2 pi radians. Half of that is pi radians. Half of that is pi over 2 radians. And half of that is pi over 4 radians. So this is 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, then 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2. Then 7 pi over 4, 8 pi over 4, which is 2 pi. Then our coordinates, center of the circle is the point 0, 0, and the radius is equal to 1. So this would be the point 1, 0, then 0, 1, negative 1, 0, 0, negative 1. Then the pi over 4 reference angle has a coordinate of root 2 over 2, comma, root 2 over 2. And when I reflect that point into the second quadrant, that is where x is negative, but y is positive. So x is negative root 2 over 2. Y is positive root 2 over 2. When I reflect the reference angle into the third quadrant, that's where both x and y are negative. And so this will be negative root 2 over 2, comma, negative root 2 over 2 as the coordinate at 5 pi over 4. When we reflect the reference angle pi over 4 into the third quadrant over the x-axis, or sorry, in the fourth quadrant has a positive x and a negative y. So we have a positive square root of 2 over 2, comma, negative square root of 2 over 2 as our coordinate in the fourth quadrant.